everybody, Melissa Brannon with Startup Prize Focus on Health. And today I'm super excited because we are doing another of our finalist spotlights. And with me today is Angel Enriquez. Hey, Angel, how are you?
Hey Melissa, doing very well. How about you?
I'm doing great. Well, I'm so excited to have you here. I'm hoping that you could just tell us a little bit about where your company is based and the problem you're looking to solve.
Yeah, for sure. So Emboa Medical is based out of West Lafayette, Indiana, where technology spun out of Purdue University, actually throughout my PhD. It was this passion project that I had during it. And it all resulted from this neurointerventional surgeon coming up to our lab and saying that he has some difficulty in treating ischemic stroke. And this is when you have a blockage that stops blood flow into the brain's arteries. And the more time that you are in this lack of blood flow state, the more likely it is that you're going to come out with some functional deficits. This can mean losing your ability to walk, talk, or even sustain function. So you really want to remove this blockage, this blood clot, as quickly as possible. And unfortunately, the surgeon was telling us that the tools available right now are not meant for these very small blood vessels in the brain. And the tools that are available, they can either try to extract these larger vessel occlusions, but not meant for the smaller ones. And this is where our research came in, and we really tried to create this novel, nature-inspired approach to try to extract these blood clots using aspiration and remove it as quickly as possible. So we're increasing the available forces compared to what's available right now.
Got it. So if I'm hearing you right, it's basically that we do have tools, but they're too large to work with something as sensitive as brain tissue and the nerves and veins, et cetera, in the brain. So Emboa Medical is, uh, what is that response? Is it to make it easier to extract? You said aspiration. Help me a little bit. Help
Of
break it down
course.
into layman's terms for those of us who aren't PhDs and kind of science.
No, no worries, no worries. So yeah, the approach to remove these blood clots right now is very mechanical based. So you either have two strategies. You either have this claw-like mechanism called the stent retriever, which can kind of grab onto these blood clots and physically remove them,
Mhm.
or you have what is called an aspiration catheter, where it tries to suck in or ingest the blood clots through negative pressure. So it just tries to really suck it in. But
Mhm.
as you go smaller and smaller, these vessels, they are very delicate and they can be easily prone to lacerations and just bleeding right in that region. And you really don't want these complications when you're dealing with the neurovasculature. And so what we've done is with the aspiration catheter, which is the safest and less costs as well of these type of tools, we've increased the amount of available forces to try to remove these blood clots by integrating nature-inspired structures in the tip of the catheter. And therefore, we're seeing increased forces when we compare to a conventional commercialized aspiration catheter.
Got it. So you're having just a higher success rate, having this additional ability to kind of latch on to the aneurysm itself or the
To
clot.
the blood clot. Yes,
Excuse
yes.
me.
In our benchtop studies, for sure. Yeah.
I love that. So you said this was kind of a passion project of yours in school. Do you have some sort of personal connection with someone who's experienced this, or how did you get involved in this type of research?
Yeah, so this project was not necessarily funded. It was more of an idea, a problem that was brought to us by a neurointerventional surgeon. And as a biomedical engineer, I really wanted to develop a device technology that can really help impact patients. And having this type of problem that is really translatable, really has that commercial pathway, just it interested me a lot. And we followed through on it. We got to a design where we really think that we can make an impact in stroke treatment.
I love that. So, you're coming down here to Shreveport. You're going to be in that room with like our 15 or so investor judges. How are you feeling? How are you feeling about being in that room? Are you excited? Are you nervous? How is it? Let us in on a little secret.
Yeah, no, I'm very excited. I think the Startup Prize is very unique in the fact how you were able to just interact with the judges beforehand in the qualifiers and really come from an approach of just having that connection with them before and understanding how to interact with these investor judges. And really now I'm focusing on just having a complete pitch deck and really trying to address those little problems or questions that might come up during the competition. So I'm very excited. I think it's going to be a great growth opportunity for us, win or lose. I think it's just going to be amazing.
I love that. And let's say you do win. What's next for Emboa?
Yeah, so Emboa is at a critical phase right now. We're really going into prototype development. And so we're partnering with contract manufacturers to create a functional prototype that we can use for regulatory activities, where we're using these new catheters, our own with our own design, to implant them into animals, establish safety and efficacy, and then do a 510K clearance with the FDA so that we can be regulatory cleared. Yeah.
Just one or two small things, no big deal.
Yeah.
Well, Angel, thank you again for coming to hang out with us. We are wishing you all the best when we come down to this year's final, and we'll look forward to hosting you here in Shreveport, or as we like to call it, a prize port. So thank you.
Awesome. Thank you, Melissa. Looking forward to it.
Yep, and Viva La Startup Prize, and we'll see you next time.